Hello and welcome to another video of the series where I talk about passing callbacks to functions. So in a previous video, we talked about all the things that are callable in C++, invocable in C++, and in this video, I'm going to talk about the problem and the solution that was given by the blog, in the blog by Philippe Groarke. I'm not still sure that I'm pronouncing that correctly, but yeah, that's what we have. And yeah, let's get into it. So the problem as introduced in the previous video is that we want to pass functions to callables to functions as parameters, and we want the code to document the signature of that callback that we're passing. So there are three solutions usually used when passing callbacks to functions. One is function pointer here. We discussed what issues it had. We have a std function here that is a slow, and we have simply just get a template parameter and templatized parameter, and this is the fastest solution that you can have. And I would actually get this as universal reference, but he's taken it as value. However, this does not document anything about what the func is supposed to be. And that is the problem that Philippe is trying to solve in this block. So his solution involves having a type that is called callback, and you would construct a callback and pass that to the function every time you wanted to pass a callback to the function. And the signature of the function that is being called should take a callback instead of just simply taking function. And this way you're taking the you're just giving the callback the type that you're expecting, and callback now can enforce that type, and also you have already documented the type that you want. So yeah, that is the whole premise of this blog. Let's get into the code that is introduced in the blog. So I have all the code copied here, and it's compiling at the moment, except that I've changed a bit of the code and it's not at the moment. But the code looks something like this. Let me fix this a second. Okay. So you have a callback. I've just copied this from the example in the blog. You have a user callback function here that has taken the callback here, and it is templatized on the type of the function. And you're telling it that you're expecting a function that takes an int and returns nothing, returns void. And that is similar to what we have here, function. And I'm passing the pointer of that function. So one immediate flaw that I saw in this code is that it does not support passing function references. So if I would go do something like ref, no, what am I doing here? All right, and I'm taking an int, and this is equal to the function that I have here, and yeah, okay. So I want to pass the ref. I don't want to pass the pointer. Let's see if this works. It doesn't. It doesn't compile because there are no specialization for function references here. There are specializations for function pointers, but not function references. Yeah. So that is one simple flaw that we have here. That is not the main point of this video. This is just something minor. It can be improved easily. So let's see how this actually works, how this code actually works, because this is kind of odd. You're expecting a callback with two template parameters here, but you're not given any here. So what is happening here? So the thing that is happening here is that you're using something called CTAD, class template argument deduction. So it goes like, if I have a class like foo, let's make it a struct. I have a foo struct that is templatized on a type called bar, and let's say that I have a bar member here, my bar, and I have a simple constructor here that is going to take no, that's going to take a const bar and construct my bar. That is just a simple thing here. Okay, so what comes to mind is why would I even do something like this? Let's see what the code would look like before C++17. So let's say this is my foo, and I'm gonna construct it with an int, right? Okay, let's comment this for now. Okay, let's not comment that. Let's use a function pointer instead. All right, let's go back to our CTAD here. So yeah, what happened is that I'm just passing the constructor an int. Why would the class not deduce from the argument what template type I would need? So that is what standard added on C++17. So I can do something like foo and give it just 5, and the type that is deduced for foo is int here. The bar for foo is int. Simple as that. Why would I need anything more complex? Why would I do this? Because it is simply deducible. And what Philippe is using here is template argument deduction. It is CTAD. And how that CTAD is working is here on this definition of the class callback. So the constructor is just taking a functor here, and from this functor, since it is used in the constructor, it can be deduced. Simple as that. So that functor is deduced, and using that, a callback selector is constructed. The callback selector, using the type, just deduces what kind of definition it will need. That is the callback base. And one of the definitions is is going to be this if the correct type is passed. One of the definitions is going to inherit from callback if you have passed the correct function signature, correct function with correct signature. So yeah, that is the whole thing that is going on here. So you're constructing a callback, the template parameter of the callback is deduced, and Philippe is going to do some kind of template metaprogramming here to deduce the signature of your function. And after deducing the signature of your function, if it can detect the signature of your function, it will inherit from a callback that is of this signature. And then when you're passing this callback, because this callback it will not be the same as this callback here, it will not have the same signature. And we can test that here simply by using a same here, same v, and we can see that this is not going to be the same as that. Equal type of this and this. Let's see what we're getting here. What kind of an error do I have here? Okay, yeah, I need to, yeah, what is going on here? Okay, yeah, I'm missing a semicolon. Argument 2 is invalid. Why is argument 2 invalid? Table type, blah blah, callback. Func was not declared in the scope. So that is the issue. So yeah, the type of func would be deduced here, and the type of func would be a pointer to a function that would be this. All right. Okay, so as you can see, this is not, this doesn't, this is, these types are not the same. And you would probably kind of think that this is not the type that is going to be deduced. You can go and do it yourself. Here you can test it yourself. I'm not going into the details. You can simply just print the same is same kind of thing. Here is same kind of statement here, like stud cout, like stud is same v. I'm actually doing this for you. Let's do it. And you would have func, and you would have, what is it, this. Let's just make sure that the type that is being deduced here is going to be the same. Okay, it's asking me to include IO stream, and it wouldn't be wrong. And let's see if I'm actually, okay, yeah. See, that func type is the same. Where is it? So this same is working here, but not working here. I can see out this as well. Let's add an end line here to complete our code. Okay, so what we're getting so far is that we're constructing a type that is not the same as the type we expect to pass, but it does inherit from it. So what is happening here is called slicing. And you can see that in the blog that is explained what exactly slicing is and how it works here. I guess it is, I saw a mention to it. I'm not sure in what depth it is explained there, but yeah. So what is actually happening is that you're inheriting from something, but when you're calling the copy assignment, which is called here, when you're calling copy assignment, you're just copying your parent, not the whole child, just part of your parent. That usually causes undefined behaviors if you're actually doing polymorphic things, polymorphic like things. But here we don't have any polymorphism, and it is safe. So that is how this is working. So why did he go through all this trouble? This simple explanation is that this standard is missing something, and that thing is that if if func can be deduced in the constructor of callback here, then the function could also deduce it. That is in this paper. So improving function templates with class template argument deduction. So there are two things that is proposing here. Mike Spertus is proposing here. The first thing is what we want. The second thing, not really related, but yeah. So what he's proposing is that, let's say we have our foo here, right? And since we have our foo here, and I'm going to make a function that takes foo, type mt, and it takes void take foo, and it takes foo of t. All right. So what that paper is proposing is that I should be able to do this. Why not? All right. Maybe not exactly that, because maybe the constructor is not implicit, because however it is in this case implicit. So what that paper is proposing is that, why can't I just construct this here? This t could be deduced from the construction of foo. So foo would first get constructed, and from the construction of foo, t would be deduced, and so t of the take foo would be deduced. That is the whole premise of that paper. Just that this should work, but it isn't. I'm not sure what the state of that paper is. I'm not sure if it's accepted or not. But if Philip had this, and he mentions that he couldn't make CTAD work, and that is exactly because of this. This feature is lacking in this standard. And given that feature, things would be a lot prettier. And we will see that when I'm going to try to come up with my own solution. I've actually tried it, and this is the exact issue that we have here. This is what is causing all that slicing and stuff like that. Otherwise, you could simply just do like this. You wouldn't need to construct any callbacks here. You would just simply pass your function and your callback here, and type would be deduced, and everything would be just fine. So this type would be deduced here. So that's another thing that is causing the issue here. Right? Let me see if I'm missing anything. All right, let's see what issues this has, this implementation has. So usually when I have something like this, let's say we are here. Let me just, yeah. Let's say we have the same example. Instead of int, I'm going to take an string. Let's say I'm expecting to pass a const ref here to my function, right? It's something that usually happens with a string. So I'm expecting to call this function with its to the string const l value of is to the string, right? That seems to be something reasonable. And there's my function. However, my function needs a copy of this string. Sometimes you need to copy your string. Why not? Let's see if this actually works. It doesn't. And to drive the point home, I'm going to do this. Let's see if it actually works right now. Oh, okay, this in your place. Okay, it worked. So let me remove the. Okay, let's not remove anything. I'm just gonna maybe put a link to the main code. All right. So this worked, but if I need a copy, but if I want to make cleaner code and make a copy of your constant string that you're passing to me, why would I not be able to do that? This is not something that we want to disallow. This is something that still matches the signature that I have here. This works vice versa. Like if I had a const ref here and you were passing me a whole L value reference, this still would not work. So the reason for this is actually the CTAD here. And the CTAD there is just going to figure out the signature of your function. And after figuring out the signature of your callable, it is going to deduce the template parameters of callback according to that. And hence this callback has already decided what exact types your callback that does take, and if it doesn't match the one that you have stated here, it will fail. Simple as that. So yeah, as you can see, the error that I'm getting here is that, let me see where the error is. No matching call to function, blah blah. Yeah. So as you can see, the signature does differ here. However, the input is this. Anyways, that is one part of the problem. The other part that comes to mind is that when you have this is something that will be soon something popular, operator, soon that I assume by C++ 20 it should have already become popular because you have things like std visit, where you want a functor that is overloaded on several types. So let's say I have one thing like this, and I have one operator that takes a string. I have one operator that takes an int. All right, and let's remove that. And let's, okay, let me just for a second let us screw up my whole examples here. Okay, let's put it here. Okay, let's call it func overload. All right. So I'm going to pass an instance of this instead of my function pointer here. Wait for it to compile. It compiled, but it did fail. Let's remove this. Wait for it to compile. What happened? I'm fairly clueless about what is happening here. Function. Okay, okay, oops, oopsie do. I did it in the wrong place. I wanted to do it here. All right. And what am I getting here? Let's remove this. Okay, so this is the thing that is happening right now. So we said that when constructing this callback from some parameter, the type is going to be deduced. But if you have two overloads or even more, which one is going to be deduced? You do not know. You can't possibly know which one is going to be deduced. So these kind of callbacks are going to be more popular now. We're getting more features on inheriting from lambdas and some features on combining multiple lambdas to have an object that has overloads on many invocation operators. So these kind of callbacks are going to be popular soon. I'm not sure if it is already popular or not, but I would assume it should be. Yeah, these are kind of useful for structures like visits, for functions like visits. So this implementation can't possibly support that because you have to select one overload. And how do you know which overload to select? You don't know. You simply don't. And that is one flaw. The other flaw is that your function is going to be copied into the callback structure here. Your callback will be copied into the callback structure here. And what if your callback doesn't support any copy or move construction? Or even worse, what if it is really heavy to copy your callback? That often happens, that you capture a lot of stuff and you don't really want to copy those things. Like for things like std visit, you don't really need to copy anything. So for example, when I'm calling std visit here, visit will just use my callback till this semicolon. Other than that, it doesn't need to copy my callback anywhere. So that's another problem. You're actually getting your callback copied here, but for std visit, we don't need to copy our callback. The other thing is that, again, if you have something like this, you have an, let me just remove this. So if you have something that works, a callback that works on R value reference, this doesn't support it. But if you have multiple overloads, again, you have two issues working at the same time to just make your compilation fail. And that would be having overloads and not supporting R value. You can't possibly call this from inside the function, since wherever your function is here, let's see here. Callback takes a copy of the function you're passing. So if I want to call this, I will never select this one because I always have an L value here. I will always have an L value here, never an R value. So let's say that is the case. Well, let's assume that this could possibly deduce that I have a callable here. I, I, I would never be able to possibly call this because let me name this. Yeah, I would never possibly be able to call this because my callback always holds an L value to the function. And whenever it calls the function, it calls the function as an L value. It calls my function object as an L value, and it will never invoke this operator here. So that's another issue with this. I hope I did make a bit of sense here on the issues of this implementation. So to just conclude what the issues are, there was the issue that it doesn't support function references. That's a minor issue that can be simply improved. The other issue was it does not support overloads. So if you have a function object that has multiple overloads of invocation operator, it will not work. Those callbacks are pretty common. It should be common because using a to visit, that's the only way you can use it. And the other issue was that it always takes a copy of your function object. And taking a copy of the function object has two issues. One, it can be a heavy operation that you don't want to pay for, and you usually don't pay for on calls to functions like visit. And the other issue is that the copy is always an L value. And if you're passing an R value and you want to invoke the R value overload of your invocation function, you will not be able to do so. Yeah, that's the whole thing I wanted to say. I hope I was clear enough and I wasn't rambling too much. Anyways, till the next video, see you guys.